My name is Joe Royer. I'm the Vice President of R&D of Geotree Solutions. We thought it would be really helpful to answer some of our frequently asked questions that we get at webinars or at lunch and learns, or when we're out talking to customers about our products. So I'm going to have one of our colleagues, Emma, ask me some questions, and we will do our best to answer them here in a series of videos. In this video, we're going to talk about design concerns and considerations for geopolymers.
What are the failure points you're designing to?
So no one ever likes to hear the term failure when they're doing a design. But to be honest, the reality is, from an engineering perspective, if you put enough load on something, it will fail. So the question is, how is it going to fail? And what are we going to use to design to the failure mode that we're going to see? So we personally have broken probably 70 pieces of pipe that have been repaired with GeoSpray, either in a load frame or in a soil box or in another system where you can apply that load. And what you will find is when you exceed the load carrying capacity of the system, it will crack. It will typically crack at the crown on the inside of the pipe. You'll then see an invert crack at the inside of the pipe. If you can observe the whole pipe, you'll see that it'll crack on the outside of the pipe in a hinge on the spring lines, and it'll then start to flex and be kind of like a hinge. But the failure mode is that initial crack at the crown, because once you've gotten that, it can no longer have the same structural carrying capacity, so it would be reduced. So what we're trying to do is we are trying to design at any time for the failure mode that's been observed in testing, which is cracking at the crown.
What design methodology is applicable?
So when we talk about design methodology, when you're talking about pipes, typically people are doing one of two things. They are designing for a rigid structure, which cracks, or they are designing for a flexible structure, which buckles, and also depends greatly on the soil pipe interaction. Because we are inside the system or inside of a hose pipe, we are ignoring most of the benefit that you get from a soil interaction. There's some involved in our design, but generally we're going to ignore for that. And what we're going to do is we're going to design standalone for cracking in a rigid methodology. And we have developed through a series of tests, and it is not proprietary to our system, basic, and we've shown it for other competitive systems, but we've shown that if you have a good arch around the pipe, you can do an analysis where you have a load that is being applied across the top of the pipe, and you are designing for a fixed arch and looking at the moment of the crown and do a moment analysis. And that does a very good job of conservatively predicting the design thickness based on all of the testing that's been done.
In the design methodology you just described, how did you verify that?
So from our standpoint, we think that anybody using a design methodology for spray applied pipes should absolutely be able to provide you test data that shows it's a reasonable approach. So we have a lot with Louisiana Tech and the TTC, which is the Trenchless Technology Center there. We did a series of experiments on a load frame where we broke 50 pieces of pipe, either corrugated metal or pre-broken concrete pipe, or damaged corrugated metal pipe that had been ovaled. And we did a series of investigations to figure out how they broke, what the loads were, and how we would handle that. And we modeled that design. We've since looked at, Ian Moore at Queen's University did some buried studies with our material. There are competitive materials that have been buried and studied in some other more recent reports. We have looked at all of that data and concluded that independent of that, as long as you have a good understanding of what the flexural strength is and a good understanding of the loads, that the design methodology of a fixed partial ring with a distributed load across it works very well and is a very conservative way to measure it. What doesn't work is trying to calculate buckling or a flexural pipe, because there is no evidence that these materials fail in flex or in buckling, or that they are a flexible pipe. They fail in flexural strength, at cracking at the crown. Hopefully this video has been instructive. If you have any questions, feel free to contact us at our website or our email, which will be on the screen, or contact any of your representatives from Geotree Solutions. Thanks for listening.